Hi, hello everyone. So welcome to the channel. So in this video we are going to discuss about the normal form or the perpendicular form of a straight line. So in the previous video we have discussed about different forms of lines and related problems of exercise 3A of Telugu Academic textbook. Right. So if you haven't gone through those videos, so please go through my channel so you can find them. And if you are new to this channel, so please subscribe the channel and share with your friends. And don't forget to like the video and watch the video till the end. Right. So in this video we are going to discuss about the normal form. So what is meant by normal form or perpendicular form? Right. So in this, so first of all we are going to have an x-axis as well as a y-axis. So this is my x-axis and this is my y-axis, and my line intersects x-axis and y-axis at two distinct points, some a comma, so some a and b. Now this line is at a distance of p, from the origin, and it will be perpendicular to this line. So this perpendicular distance, so since we have this perpendicular distance, so we call it as perpendicular form or normal form. Right. Now let us see what is a perpendicular form and how to obtain the equation of line using this form. Right. So in this perpendicular form, this perpendicular line is making an angle alpha with the positive direction of x-axis. Then it is at a distance of p from the origin. Then this line equation is given by, so this line equation L is given by, so this L is given by it is nothing but x times of cos alpha plus y times of sin alpha is equal to p. So here p is nothing but my perpendicular distance, and this alpha is nothing but the angle made by the normal, with the positive direction of x-axis in anti-clockwise direction. Right. So here if you observe, this alpha is not the slope. So here the value of alpha ranges from closed 0 to open 360 degrees. So it ranges from 0 degrees to 360 degrees. Right. So here alpha is not the inclination. So to find out this line or the normal form, x cos alpha plus y sin alpha is equal to p. That means here the two entities that are given are alpha and p. Okay, using these two entities we are going to find out the line of, so the line equation of my given line. So for that what we need to have, so since this particular line is perpendicular, consider this point as some c, and to find out this point c, what I am going to do is, so I am going to drop a perpendicular onto the ray OX. So let this point be some d. Right. So this point c is nothing but obtained by considering the distance OD comma CD. Right. So if I take this distance OD and this distance CD, then those becomes the x coordinate and y coordinate of my point C. Next, since origin is nothing but given by 0 comma 0, if I know the slope of OC, then directly considering the perpendicular slope of OC, I can take the slope of line AB. Right. So using those two things we can directly find out the line equation AB. So for that, so first of all I need to find out OD as well as CD. So for that what I am going to do, I am going to consider triangle ODC. So in triangle ODC, since I know the hypotenuse, right, so when I know hypotenuse and the angle, so directly I can use sin alpha and cos alpha. So sin alpha how much? So sin alpha is nothing but opposite side to theta by hypotenuse. Right. So from this what I can directly say, so CD is equal to p times of sin alpha. The same way if I consider cos alpha is nothing but OD by p. So from this what is the value of OD? So OD is equal to p times of cos alpha. So directly I can write it as, so p cos alpha comma p sin alpha. So I got the value of point C. Now directly I am going with the slope of OC. So slope of OC. So slope of OC is given by, since we know 2 points, y2 minus y1 by x2 minus x1. So directly I can write as p sin alpha minus 0 by p cos alpha minus 0. So from this I can write as p sin alpha by p cos alpha. P gets cancelled. I can write as sin alpha by cos alpha. Now since I need about line AB, right? So since I need about line AB, directly I can write as slope of AB. So slope of AB is nothing but perpendicular slope of OC only, no? That means I know the condition, so directly write minus and reciprocate the values. So this becomes minus cos alpha by sin alpha. Now since I know I am having a slope of AB and I am having a point C which is on AB, by using point slope form I can write down the equation of AB. So from this equation of AB is given by y minus y1. So y1 is nothing but CD value, so which is nothing but p sin alpha is equal to minus tan t, so minus slope, so slope is nothing but minus cos alpha by sin alpha. So be careful. So this is my slope of AB, so minus cos alpha by sin alpha into next x minus x1. So what is x1 here? P cos alpha. Now when I do cross multiplication, so this becomes y sin alpha minus p sin square alpha is equal to minus x cos alpha plus p cos square alpha. Now bringing out the terms which contains x and y to one side, so from this I can write as x cos alpha plus y sin alpha is equal to p times of cos square alpha plus p times of sin square alpha. Now clearly, so from these two terms I can take common p, so this becomes p times of cos square alpha plus sin square alpha. So cos square alpha plus sin square alpha is nothing but identity, so p times of 1. So clearly what I got, so I am going to get this particular line equation, x cos alpha plus y sin alpha is equal to p. That means you are going to have everything in terms of angles and the distances, right? So x times of cos alpha plus y times of sin alpha is equal to p, where p is nothing but perpendicular distance from origin to the given line, and alpha is nothing but the angle made by that particular perpendicular line with the positive direction of x-axis in anti-clockwise direction. Okay, now let us see how to write ax plus by plus c is equal to 0. So what is ax plus by plus c is equal to 0? So it is the standard form of line equation, straight line equation. So we need to convert this into normal form or perpendicular form. So how to convert the given line equation in normal form or perpendicular form? So let us see that. So for that what I are going to do is, so first of all transpose that c to the other side. So transpose that c to the right hand side. Then how can I write this as ax plus by is equal to minus c. Now here you need to see that this minus c is positive or negative. This whole value minus c is positive or negative, right? So if this is positive, that means this right hand side, if it is positive, then you can directly proceed. If it is negative, so if ax plus by is equal to minus c, then this minus c can have two possibilities. The first one is either it can be positive or negative. So if it is positive, then what you are going to do is, so directly divide this equation with root a square plus b square. Then this becomes ax by root a square plus b square plus by root a square plus b square is equal to minus c by root a square plus b square. So what I said here, if minus c is positive, so positive, then directly divide with root a square plus b square, then write it as x into a by root a square plus b square plus y into b by root a square plus b square is equal to minus c by root a square plus b square. Now this has been converted into our normal form. So you consider this as cos alpha, this as sin alpha, and this particular value as p. Then you can clearly read it as x cos alpha plus y sin alpha is equal to p. So this is one situation, right? For suppose if ax plus by is equal to minus c, so this minus c is negative. So if this minus c is negative, what we need to do is, so you need to make it positive. So how can I make it positive? Directly multiply both sides with minus, then this becomes positive, right? Then divide with a square plus b square. So then divide with root a square plus b square, then this becomes minus a by root a square plus b square into x plus minus b by root a square plus b square into y is equal to c by root a square plus b square. Again if you observe, so this is nothing but cos alpha, this is nothing but sin alpha, and this is nothing but my p value, right? So here also we have converted into x cos alpha plus y sin alpha is equal to p form, right? So while doing the problem, so be careful, always this right hand, so when you transpose the constant, this right hand term should be positive. If it is not positive, then directly multiply with minus on both sides. Then proceed with the problem. What is the procedure? Directly divide with root a square plus b square on both sides. So some may have a doubt. So why we are dividing with root a square plus b square. Now if you see, we know cos square alpha plus sin square alpha is equal to 1, right? So this is nothing but my identity. I need to obtain this identity, right? Now when I consider this, a by root a square plus b square plus b by root a square plus b square, if I square it, what I am going to get? A square by a square plus b square plus b square by a square plus b square, so which gives me 1. So that means when I consider this as cos alpha as a by root a square plus b square, that means it is satisfying my equation. Or otherwise what I can say here is, when this is my angle alpha, and if AB are two sides, then automatically hypotenuse is a square plus b square. So for suppose if this is b and this is a, then I will have cos alpha is equal to a by root a square plus b square, sin alpha is equal to b by root a square plus b square, right? So to get this particular hypotenuse value, we are going to divide with the root a square plus b square on both sides, right? Now clearly from both the equations, in both the cases, what is the value of p? P is nothing but minus c by root a square plus b square, which is a positive value, as well as here c by root a square plus b square, which is also a positive value. That means perpendicular distance is always positive. See here, perpendicular distance from where you are calculating? From the origin, right? So from this directly what I can say is perpendicular distance from origin, perpendicular distance from origin to the line. So what is the line we have used here? Ax plus by plus c is equal to 0. So perpendicular distance from origin to the line ax plus by plus c is given by simply mod c by root a square plus b square. So what is the formula? So mod c by root a square plus b square. So this is nothing but the most important formula, right? So if you want the perpendicular distance from origin to the line ax plus by plus c is equal to 0, it is given by modulus of constant by root a square plus b square. So why we are considering modulus of c? Because distance is always positive. So whether c is negative or positive, so based on that we are going to consider this value, right? So likewise we can find out the perpendicular distance from the origin. Now for suppose instead of perpendicular distance from the origin, so if you ask from some other point, then how to find it? For suppose I need perpendicular distance from some point, okay, so then what I should do? So for that what we can simply do is, for suppose this is my x-axis and this is my y-axis, and this is my line L, which is nothing but ax plus by plus c is equal to 0. So this is my line equation. And for suppose if I need from x1 comma y1, so if I need a perpendicular distance from this point x1 comma y1 to this line, then how to find this? Since I know from origin it is nothing but modulus of c by root a square plus b square. Now for suppose if from x1 comma y1 he is asking, then what I am going to do is simply this origin I am going to shift here. So when I shift the origin, so shifting origin means nothing but we are talking about translation of axis. We are going to talk about translation of axis. Okay, then so whenever I do translation, this origin is shifted to x1 comma y1, then my line equation also changes, no? So that also we need to write here, right? So what is new origin? So new origin is given by x1 comma y1. Then what about new point? So what about new point? Capital X comma capital Y. Then so from this original point I can write it as x1 plus capital X, and small y can be written as small y1 plus capital Y. So already we know small x is equal to capital X plus h, small y is equal to capital Y plus k. So instead of h comma k we are going to have x1 comma y1, because origin is shifted to h comma k, no? Here the origin is shifted to x1 comma y1. Now when you are having the original points in terms of the new points, then what I can do, I can get the transformed equation, right? So the transformed equation is given by a times of, so instead of original point x I can write as x1 plus capital X plus b times of y1 plus capital Y plus c is equal to 0. Now since when I shifted the origin from 0 comma 0 to x1 comma y1, then this line will be in the translated terms. That means you are going to get this equation in terms of capital X and capital Y's. That means you can write as a into capital X plus b into capital Y plus a times of small x1 plus b times of small y1 plus c is equal to 0. Now this is nothing but my translated equation. So in this translated equation, the axis, new axes are in terms of capital X and capital Y, right? The new axes are capital X and capital Y. That means capital X coefficient is small a, capital Y coefficient is small b, and this is nothing but my constant term. Now since this is translated equation, directly what I can say, the perpendicular distance, so this origin 0 comma 0 becomes 0 comma 0 here, right? So from that what we can say, perpendicular distance already we know, no? So perpendicular distance from the new origin, so the perpendicular distance from new origin, what is that? x1 comma y1 to this line. So this line is nothing but given by, so what I can say, so perpendicular distance from x1 comma y1 to the line ax plus by plus c is equal to 0 is, so what is the constant here? So constant is modulus of ax1 plus by1 plus c divided by root. So here also x coefficient is small a, y coefficient is small b, so directly I can write as root a square plus b square. So clearly this is nothing but the formula which we can use to find out the perpendicular distance from x1 comma y1 to the line ax plus by plus c is equal to 0. Okay, so here what we can say, for this line equation from this origin the perpendicular distance is this, right? So clearly the distance from perpendicular distance from x1 y1 to ax plus by plus c is given by modulus of ax1 plus by1 plus c by root a square plus b square. So likewise we can find out the perpendicular distance from a point to a given line. Okay, so remember this formula. So this formula is very, very important. So this formula we are going to use in many cases. Okay, in many situations we are going to use this formula. So remember this formula, right? Next, moving on to the distance between parallel lines. Distance between parallel lines. So first of all, what are parallel lines? So parallel lines means the two lines differ only by their constants. So parallel lines means the distance between those two lines is always the constant, right? For suppose I am going to consider two lines which are parallel to each other, right? So I am going to consider two lines which are parallel to each other. So these are nothing but the two lines, and the distance between those two lines is always constant, and so that is nothing but distance is nothing but perpendicular distance. For suppose this line, if I consider ax plus by plus c is equal to 0, then this line will be, so for suppose if I consider this constant as c1, then its parallel always will be in the form of ax plus by plus c2 is equal to 0. It will be of the form ax plus by plus c2 is equal to 0. That means parallel lines will differ only by their constants. Only by their constants. That means here the x coefficient, whatever it is, the same x coefficient will be. Whatever the y coefficient that we have, the same y coefficient will be. But constants will be different. But in some situations, so they will be as multiples. In some questions, they will be giving it as multiples. In such cases, what we need to do is, so either you multiply with a constant to make the other equation also with the same a and b, same x and y coefficients, or divide with some constant. Okay, so those things, so you'll clearly understand when we do the problems. So here, whenever you are going to find out the so distance between parallel lines, always their x and y coefficients should be correspondingly equal. So after doing that only you need to proceed with the problem. Okay, always do remember this. Now let us move on to find out the distance between these two parallel lines, right? See, for that what I am going to do is, so I am considering some point P. So let this point P be some x comma y. So from this point I am going to find out this perpendicular distance. So if I find out this perpendicular distance from this point to this line, then simply what I can say, so let this line equation be some L1 and this be L2. So that means what we are going to do, we are going to use the concept of perpendicular distance, right? So first of all, this point P, x1 comma y1 is lying on this line L1, no? So from that what I can say, so a into x1 plus b into y1 plus c1 is equal to 0. So from this what I can say, ax1 plus by1 is equal to minus c1. So let this be equation number 1. Now I need to find out this perpendicular distance. So for that what I need to do, what I can say simply, so distance between parallel lines, so distance between parallel lines L1 and L2 is nothing but equal to perpendicular distance from point P, x1 comma y1 to the line L2. So distance between parallel lines is nothing but equal to perpendicular distance from this point to this line L2. So already we know perpendicular distance from point P to L2 is given by modulus of substituting this point in this equation. That means a into x2 plus b into y2 plus c2 divided by root over, here x coefficient and y coefficients are same, so directly I can write as root a square plus b square. Now from equation number 1, how can I write this? ax1, sorry, here it is not, here the point are x1 and y1, no? So this is ax1 plus by1. So ax1 plus by1 plus c2 by root a square plus b square. Now from equation number 1, what is the value of ax1 plus by1? I can write it as minus c1, no? So directly I can write it as c2 minus c1 by root a square plus b square. So the distance between the two parallel lines is given by modulus of c2 minus c1 by root a square plus b square. So it is nothing but the distance between two parallel lines. For suppose if I am taking one example, 3x plus 4y is equal to 5. Next, 6x plus 8y is equal to some 12. 6x plus 8y is equal to 12. Here if you observe, here x coefficients are different, y coefficients are different. But if you observe, when I multiply this particular thing with the 2, then I am going to get same corresponding x and y values. So that means first of all what I need to do, I need to multiply this equation with 2. Then this becomes 6x plus 8y is equal to 10. Now directly, so after converting only I can solve the problem. So what is the distance between these two? So c1 minus c2. So you can directly take this constants. So both are on the same side. So directly I can take 10 minus 12 by root over a square plus b square. So 6 square plus 8 square. So from this 10 minus 12 is nothing but modulus of 2 is 2 by 6 square plus 8 square is 10 square, which gives me 10. So what is the distance? So 1 by 5. So likewise we can find out the distance between two parallel lines. So whenever you are having different x and y corresponding values, so first of all we need to make them either by multiplying or by dividing with some constant. So it is easy to multiply, sometimes it becomes easy when you divide. So these things you need to remember while solving the problems. Next, moving on to the symmetric form. So symmetric form. So what is symmetric form? So for suppose this is my x-axis and this is my y-axis, and for suppose if a line is given, so which is passing through a point x1 gamma y1. If this is my point x1 comma y1 and it is making some angle of inclination, so some inclination with the positive direction of x-axis. So this is my line L, so which is passing through a point x1 gamma y1 and it is making an angle of angle of inclination theta with the positive direction of x-axis. Then the symmetric form. So symmetric form is nothing but the form which we obtain from point slope form, right? So what is point slope form? So y minus y1 is equal to m into x minus x1 only, no? So here since I know theta, so instead of m I can write it as, so this I can write as y minus y1 is equal to tan theta into x minus x1, right? Again I can write tan theta as sin theta by cos theta. I can write as sin theta by cos theta into x minus x1. So when I arrange these values, so how can I arrange this? X minus x1 by cos theta. So I am keeping this cos theta under this. So x minus x1 by cos theta is equal to y minus y1 by sin theta. So if you observe these things, so here you are having x, here you are having y. Here instead of x you are having x1, here y1, here cos theta, here sin theta. That means correspondingly if you observe this, these two are looking like symmetric values. So instead of x you are having y, instead of sin you are having cos. So this type of equation we call it as the symmetric form. Here this type of form is nothing but called as symmetric form. Here theta should not be 90 degrees. So here if theta is 90 degrees, so what will happen? Left hand side value will not be defined. So from that what we can say? So here theta we should not consider it as 90 degrees. So other than 90 degrees, from 0 to 180 degrees, so any value we can consider. Okay. So likewise you can write the symmetric form. So symmetric form is nothing but one form of point slope form. That's it. Okay. Next, moving on to the parametric form. So parametric form means nothing but, so you will be having a parameter here. So you will be using one variable, so one particular variable as a parameter or a symbol as a parameter, right? So let us see what is parametric form. So in parametric form, so what we are going to have is, so we are going to consider a coordinate axis. So on this coordinate axis, so we are going to have a line L and it will be making some angle theta inclination with the positive direction of x-axis, and there will be a point some x1 gamma y1 is given, and the locus of a point x comma y is also considered, right? So here the locus of point is x comma y. So what are the things that are given? Here a point x comma y, x1 comma y1 is the point through which my given line is passing, and it is making an angle of inclination theta with the positive direction of x-axis, right? Then this particular line equation is given by x is equal to x1 plus r cos theta, y is equal to y1 plus r sin theta. So what is this? X is equal to x1 plus r cos theta, y is equal to y1 plus r sin theta. So sometimes it will be considered minus also. Then x is equal to x1 plus r minus r cos theta, y is equal to y1 plus r minus r sin theta. Now how do we obtain this particular thing? So already from the symmetric form we have x minus x1 by, so we have from symmetric form x minus x1 by cos theta is equal to y minus y1 by sin theta. Since these two are equal, so I am considering this equal to some r, some parameter r. So from this what I can say, so x is equal to, so on comparing, so since these are proportional, then I can write it as, so x minus x1 is equal to r cos theta. The same way y is equal to, sorry, y minus y1 is equal to r sin theta. Now from this what I can simply say, so x is equal to x1 plus r cos theta, y is equal to y1 plus r sin theta. So x is equal to x1 plus r cos theta, y is equal to y1 plus r sin theta. So likewise from symmetric form we are going to have this parametric form. But what is the value of r? So for that what we are going to do is, so let this be equation number 1 and let this be equation number 2. So when I add, square it and add it, what I am going to get? X minus x1 whole square plus y minus y1 whole square is equal to r square cos square theta plus r square sin square theta. Now from this, if I take r square as common, this becomes r square into 1, which is nothing but x minus x1 whole square plus y minus y1 whole square. Since I need the value of r, from this r I can write it as square root of x minus x1 whole square plus y minus y1 whole square. So from this clearly what I can say, what is the value of r? So r is nothing but the distance between that point x comma y and x1 comma y1. Okay, from this r is equal to distance between this x comma y and x1 comma y1. So this is nothing but the parametric form. So x is equal to x1 plus r cos theta, y is equal to y1 plus r sin theta. So minus, so when we are going to consider minus means, so this point, particular point x comma y, so this distance is r, right? So this distance is r. So this particular x comma y, since this is the locus of the point, so this x comma y can also lie on the other side of this x1 comma y1. So if you want to find that particular point, so we are going to consider minus as well, right? So such type of situations also arises, right? So this is nothing but my parametric form. So what is parametric form? X is equal to x1 plus r cos theta. So first of all you need to consider plus. So x is equal to x1 plus r cos theta, y is equal to y1 plus r sin theta. So what about theta? Theta is inclination now. So inclination can be from 0 to 180 degrees. So that you need to remember once again. So theta belongs to closed interval 0 to open interval 180 degrees. So this you need to remember once again. Here theta is the inclination and r is the constant. So here r is constant and theta is a variable which is nothing but being changed, right? So r is nothing but distance between those 2 points. So the distance is always positive. So that's why we are going to consider this as modulus of r. Okay, right? So this is about the parametric form, so which is one of the important forms when you are given with angles. So when you are given angle, so you can make use of parametric form, okay, to make the problem solve in an easier way. Okay.